Alright guys, let's, a little bit of time we got left, let's take a look at this. Tomorrow, don't forget I put chapter 1's homework stuff up on the website. I want everybody, you desperately want to try that out tonight. Tomorrow is going to be basically all about any questions you have from that. And then the next day we're getting right into chapter 2. So you got to come ready tomorrow with questions from that chapter 1 assignment. So let's look at these. So that first one, this is going to happen to us pretty damn quickly. And I just want to point something out real quick. What happens if you try to let x be 2? What happens if you try to let x be 2 there? Is that what I asked? No. So I'm just pointing something weird out. If x is 2, what happens to this? It's not undefined, actually. It's sort of related to undefined. And not only is it 0 on the bottom, it is also 0 on the top. It's something called indeterminate, which is somehow worse than undefined. Right? Because it's not only divided by 0, it's also... So 0 on the top of anything is 0. Anything divided by 0 is infinity. So you got, holy shit, it's infinity and 0 at the same time. But when you do this, some of you guys remembered what to do. You weren't sure what to do after you applied it, though. What do I attack this with to make it not irrational? Yeah, the conjugate. This always makes it, sounds like math really is a foreign language from conjugated verbs in math. The top you actually leave alone for right now because something might cancel. That's with fractions you want to try to not multiply. But the bottom, the whole reason I do the conjugate is so when I multiply it becomes simpler. So I go ahead and multiply the bottom out, and I'll get 1. Minus this plus this, of course, I built it so the middle terms cancel. And radical something times radical, that same thing is that thing. Half of this times half of this makes a whole that. Aw. But the big mistake people make there is they do this. That ain't right. It's supposed to subtract the result. So then you get x minus 2. What do you get on the bottom? Minus x. Yeah, you get 2 minus x. Right? 1 minus x plus 1. What happens between these two? Are they the same?
No.
No, so you can't just cancel them unless you realize they're almost the same.
Minus.
Yeah, they would cancel to be -1, right? You guys see that? How are you doing? If it's coming back to you, let it come back. It's first day. Some of you guys are like, dude, man, I had a really good break. It's all gone. So I'm just trying to restart your engines here a little bit. So give yourself a little bit of a break today. So there's -1. So now look at this. The result. Can I plug a 2 into the result? Will it be okay? Of course it will. What do you get when you plug a 2 in? You get 1 plus 1. You get -2. So this function, it wants to be -2 when you plug a 2 in. But when you plug a 2 in, it's indeterminate. Yes?
Can you explain why you got the -1?
Oh, here?
Yeah.
Yeah, so if I have x minus 2 over 2 minus x, what can I take out of the top? I can take a -1 out. Because that would make the -2 become positive, that make the x become negative, and then these are the same. So that's why it's -1. Whatever x minus 2 is, 2 minus x is the exact same number, just the opposite sign. I like it. Does that sound familiar? Yeah. A little bit? Alright. So that's the end. Then you can distribute the negative if you want to, blah, blah, blah. 1b, now here's interesting. People hate logarithms. And when I teach logs, I try to make people realize square roots are easy, right? What's the square root of 49? Because you know the symbol is asking you, what does it take 2 of to make 49 when you multiply, right? You know what the symbol means. This symbol you're not as familiar with because you learned it later in life. So you're not as immediately aware of what the question is. The question this asks you is, what power does this base need to become this? So if it was log 8, what power does 8 need to become 8? 1. So the answer to this has to be less than 1. How do you cut 8 down to become 2? What power do you apply? A 1/3. Yeah, remember, powers are also roots. So then you're thinking, what root do I apply to 8 to make it 2? A cube root, so it's a 1/3 power. 1/3 of 8 multiplicatively is 2. Because 8 is 2, 2, 2. 1/3 of those is 2. Okay, enough of that. The reason I assigned this problem is this mistake drives me insane. Oh, if you wrote that, don't even look at me. Don't give me any sign that, oh, I see some people erasing. Dear God, let go of this. Why is this not true? Does anybody know?
Because it doesn't practice.
What are roots based on? What are roots based on? What operation are roots based on? What's the square root of 49? Because 7, oh, it's based on multiplication. So they will not play well with addition. What's the square root of 13? Is it nice? No, it's not the square root of 4 plus 9. It's not 2 plus 3. It's not 5. Right? I know you can't read that, but you know what I said. You with me? Square root of 4 plus 9 is not equal to 2 plus 3, because then the square root of 13 is 5. Holy shit. So let go of this. This is going to happen a lot in this class. And that's the quickest way to make you cry is if you do this over and over again. So the only thing you can do this is take the 4 out, and of course then square root of 4 is 2. And that is it. That's all you can do. What about 2a? How do you kill fractions in an equation?
Greatest common factor.
Yeah, the one time you can kill fractions is if there is an equation, I can just multiply by the LCD. Right? Because I have two sides. I'm allowed to do that. If that one there, I couldn't do that. So I just multiply everything by like this. So 15 is going to stay 15. That's going to pick up this and that. That's only going to pick up x, because the x minus 4 would cancel. Are you guys with me? And now it's just a question of putting stuff together correctly. Negative 2x squared minus 8x minus x is minus 9x. Plus 8x, there you go, Jeff. Plus 8x minus x is plus 7x, is that right? Yes. Plus 15. This will actually factor. I don't know if anybody got it to factor. So it's 30, 10, and 7. So 10 would be 2 and 5. And 3. I want the 10 to be negative and the 3 to be positive. There. Cool. Whatever way you factor, you should have a way to factor. And then your answers would be what? Yeah, negative 3 over 2 or 5. I like it. And neither one of them make it undefined, so both of them are valid. Cool. Okay. Where are we at? Sorry? Negative 3 over 2. Yeah. It does. You have to trust me. Totally. It has to work.
X minus 4 on the right side.
Say again? No, x minus 5.
On the problem,
Yeah.
on the right side,
Yes.
1 over x minus 4.
Yep.
So negative minus negative is going to be negative, right? So 1
Sure.
Negative? Okay, we divide by negative, right? It's not 0.
Exactly.
Proceed.
Okay.
Proceed.
So what about 2b? Yeah, good. I like it. Move the 2 over. So when I teach this, I tell people isolate your radical element. So it's kind of like tyrant class. You're in charge of a country. You isolate your radical element, and then you kill them. So you add the 2. Eventually, I got to square so I can free my variable up, right? So I square now, so then the square root will go away. 3x plus 1 equals x squared minus 2x plus 1. And I'm doing this real quick and gross because this should be simple now, right? It should have been simple from the beginning. Subtract, get x squared minus 5x equals 0. Factor. Possible answers. Do those both work? You have to check your work. Why do you have to check your work? Sometimes, well, yeah, why? Math, stupid math. You give me freaking numbers that don't work. What the hell's wrong with you, math? And then math is like, oh, I'm sorry, man. There's no way at this point we can know. What can a radical not equal? What kind of number can a radical not equal? Negatives. And at this point, did I know that this was negative? Do I know what x minus 1 is? I have no idea. But if x were 0, x minus 1 would be negative. So this is just math saying, oh, when you squared, you lost information about what was negative, what was positive. This won't work, dude. I'm sorry. It's not math's fault. It was our fault. We just didn't know it. So if you plug 0 in, it shouldn't work. But if you plug 5 in, you'll get square root of 16 is 4 minus 2 is 2. 5 minus 3 is 2. It works. Yay. So then you cross that, circle that. Cool. How are we doing so far? Guys all right? I'm going very fast because this stuff you should do.
Let's see.
I think that's beyond the time I have, isn't it? So why don't we'll pick it up from there tomorrow and just bring your questions from chapter 1. If you need an add code, come up and see me. Thanks, guys.
Can you remind me? I did. I know how to do this. I forget.
So if you want to do it a very technical way, multiply these, factor that to make that, and then you split up the middle term using those numbers. And now you can group. 2x plus 3, x minus 5. You can take out an x minus 5.
I suppose you think it's very hard. Yes. So it gives me